Hi, yeah, so here we are with question 2 of part B and part A of that question 2 for assignment 1. And basically, what we're given here is a simple RL circuit. And we're told that basically there's a switch which is at point 2 and it's going to go to point 1. And we're supposed to find a basic function for IT once it goes from point 2 to point 1. So when that happens, if you notice, the current's constant throughout the circuit in the sense that even though the current's changing, the current going through Vs, R, and L is going to be the same. Whereas the voltage, since it's in series, VR across VR and VL is going to be different. So in essence, Vs is going to be your total circuit, total voltage in the circuit, and the rest of the rest of the voltage could be breaking up into VR plus VL. Now for the current going, there's a relationship between the current and the voltage going through a resistor, which is V equals IR, and a similar relationship exists with an inductor, which is V is equal to L di over dt. And basically, what you have to do is substitute those in over there respectively. So this is going to be our VR in this case, and our VL. So if we do that, we get an equation similar to Vs is equal to IR plus L di over dt. And we could take the IR to the other side and get a Vs minus IR is equal to L di by dt. Now what I'm going to do is I'm actually going to get this Vs minus Vr underneath this di and take this dt and L to the other side. What's important is really to get the di and the I onto one side of the equation, and the constants could be anywhere. They don't really affect the equation as a whole. All you really need to make sure is that the I and the di are on the same side, since there are no t's. So I'm just doing it like this. You can do it another way. Hopefully you should get the same answer. So if you go ahead and do that, you'll get something like 1 over L dt is equal to 1 over Vs minus IR di. I'm just going to go ahead and erase this off here. And basically you have to integrate both sides for t and for I. And you're going to get your L, 1 over L is just a constant, so all you're actually going to get is 1 over L t plus c, which is equal to, well, it's going to be a ln of something. Just to, a lot of people make this mistake, they're just going to write ln Vs minus IR plus c, but it's not actually that. You have to make sure to, again, like I've mentioned in my previous questions, it's better to actually go forward and go through with the integration step by step, just to make sure you don't make a mistake and realize down the line that your whole equation's wrong. Even they do, why not get perfect, right? So let's take our u is equal to Vs minus IR, and your du by di is going to be minus r. So your du over minus r is going to be your di, and we can just go ahead and substitute that into that equation. So you have 1 over u di over negative r. Take the negative r outside, so you have something like 1 over u du. Oh, sorry, this is a du. And that's a basic ln, so it's negative r ln absolute value u plus c. Remember the absolute value, guys. You don't know if the thing inside is negative or positive, since they're all undefined variables. So you're going to get a simple ln Vs minus IR in absolute value plus c. So that's going to be your integration. And so we can just rewrite it up here. Minus r ln Vs minus IR plus c. Now what we're going to be doing is taking the exponential of both sides, and to do that, before we do that actually, you probably want to get everything to one side except the ln, so you can have a clear you can cancel the ln out directly. So what we can do is get the c to the other side. Since they both are c's, they're obviously not the same c, so it'd be best to label like c1 and c2. You're going to get a c3 by combining these two, and what you'd probably want would be t over L plus c3 is equal to negative 1 over r, all multiplied by ln Vs minus IR. You'd probably want to get this r to the other side, so you can get an equation similar to a negative RT over L plus C4. I'm just saying C4 because when you multiply both sides by negative r, it'll become negative r times C3, which will get absorbed since it's a constant, to give you a C4. And this is all equal to your ln Vs minus IR in absolute value. Take the exponential of both sides now, and you should get an equation similar to this. E to the negative RT over L plus C4 is equal to Vs minus IR. This in turn could be written as e to the negative RT over L multiplied by e to the power of C4 minus Vs, since I'm getting the Vs to the other side, minus IR. This again could be written as C5. So you have a C5 e to the negative RT over L minus Vs. And now what I'm going to do is try to isolate the I onto one side, because at the end of the day you need a function of I in terms of t. So we have to divide both sides by negative r, and that's basically going to make this into a positive number and this into a negative, and give you a, basically, I'm just going to leave this outside, so 1 over r, which is equal to your I. And this could be rewritten as 1 over r multiplied by Vs minus C5 e to the negative r t over L is equal to I t. So that's your final equation. As you notice, we do have a c in it, so the best bet would be to actually get rid of the c using the initial equation that they've given us. So we'll do that right now actually. So the initial condition is quite simple. It's at t equals 0, I is equal to 0, so you'll get something as 0 is equal to 1 over r Vs minus C5 e to the power of 0. What you could do is multiply both sides by r, so this can go away, and r times 0 is going to be 0. And e to the power of 0 is also equal to 1, so you're just left with a 0 is equal to Vs minus C5, which means your Vs is equal to your C5. And you can just go ahead and substitute that in over there into your final equation. So that's Vs minus Vs e to the negative RT over L. You can take the Vs out, so you get